guys. So the reason that they were all dancing is because they were excited about taking math notes. I thought you'd find that humorous. Okay. We are going to pick up on our notes from yesterday. These last 3 domain problems up here we're going to go over in class. So let's take a look down here. Suppose you want to write a function for how long it takes for you to drive to work. This would depend on how fast you drive, assuming you already know the distance. How fast you drive depends on the amount of traffic. When do we see the most amount of traffic? Okay, so these are all things that you can relate to real life. Okay, if we call the amount of traffic f at the time of day t, and then f is a function of t. If we call the amount of time it takes to get to work w, then w is a function of t as well. We can call this the function w of f of t. The amount of time it takes to get to work depends on the amount of traffic, which depends on the time of day. We call these composite functions. So like everything's relatable here. Okay. Now obviously this is a very real-world example. I'm going to relate it to math more down here. But in class we could have this discussion for a while about how we can have things relate on top of each other like that. The composition of 2 functions. Using the range of one function as the domain of the second, i.e. we will substitute an entire function into another function. If you had f of g of x, that's how we say it. I know it looks like fog, you hear that a lot, but it's just f of g of x. You would plug x into g, then plug the new g function into f. This is read as f of g of x. Okay. So always work from the inside out. This is the important thing. Okay. You'll hear me say this over and over and over again. All right. I just think it's cool the way that my hand goes back and forth in the video. Always work from the inside out. So down here, let's take a look. This is my function f. If I have -4 for x, these are all xy's. Okay. Then I'll have an output of 3. If I have an input of -2, I have an output of 0, so on and so forth. So let's work our way across. I'll see if I can explain this to you guys. Easy enough. F of -1. I have f and g. Here's f. Go to where you see x. -1 is my x value. What's my output? +1. Done. That's all I'm doing there. Okay? See how simple that is. If I come over here, g of 3, I'm not going to look at the f one. I'm going to look at g. Where do I see 3 as my x value? Boom. What's my output? 6. Okay. Here is the composition. I'm going to rewrite this as f of g of x. Okay. Now they told me that my x is 10 in this problem. Okay. So here's what we're going to do. I'm going to cover this up. I'm going to work inside out. G of 10, which is -4. Okay. I'm going to replace this with -4, just like I did in the last problems that you guys thought was easy. See, all I did was replace g of 10 with -4. Well, now I look at -4 for f. 3. Done. See how simple it is? That's all we're doing today. All right. Here, f of g of -2. Work inside out. Cover it up. I don't care if you do this. I always do it too. -2 is -1. Okay. Just replaced it. F of -1 is 1. Simple, right? And then I can switch it up. F of -1, which is over here, which is +1. -8. Okay? Inside out. It's a great E6 song, by the way, too. I would swallow my pride, I would jump. You get the idea. It's a good song. Check it out if you haven't ever heard it. Okay. So now let's step the difficulty up a little bit, see how we do with this. Given f of x is equal to x plus 1 and g of x is equal to x squared minus 5, find the following. I write this as f of g of x. Guys, I know the numbers on the last page are simple. I'm doing the exact same thing. G of x is this, x squared minus 5. Okay, all I'm doing is replacing g of x with x squared minus 5. We're cool so far. Now look at what f of x is. F of x is something plus 1. X plus 1. I'm replacing the x with whatever the last thing is in this parentheses. Okay, that's the hardest part. I'm just replacing the something with whatever's in the parentheses. All I gotta do is clean this up. X squared minus 5 plus 1. Guys, what's -5 plus 1? Minus 4. Done. Okay? So watch how this works in reverse. Reverse, reverse. Look inside out. F of x is x plus 1. Okay? Now check this one out. This is a little bit more difficult. G of x is something squared minus 5. Something squared minus 5. The something being squared is the last thing in the parentheses. X plus 1. I have to FOIL this out. X squared plus 2x plus 1 minus 5. Again, that's foiling. I hope you guys are cool with that. 1 minus 5 is minus 4. Okay? It gets even easier when we put numbers in here. Check this out. If I plug a 3 in for f, okay, what this is, little thought bubble here, it's x plus 1, and I'm replacing the x with a 3, which gives me 4. So that means this becomes a 4. There's my work up here if you need it. Hopefully you guys are cool with 3 plus 1. Now I'm doing the same thing. Everywhere I see my g, everywhere I see an x, I replace it with something squared minus 5. The something is 4. It's easier with numbers. 4 squared is 16, minus 5 is 11. Here we go. Okay. So practice is key with this. Let's continue to move on. F of x equals blah, blah, blah. G of x, blah, 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 blah. Okay, here we go. F of g of x. So I'm working inside out. G of x on the inside. Square root 3x. Okay. Now, look at my f. They're starting to get a little more difficult. It's 4 something squared minus 1. Where am I getting this from? It's right here. It's my f, my outside function. Okay? The something squared is the square root of 3x. What happens when you square a square root? You get just what's underneath it. Okay? 4 times 3x is 12x minus 1. Boom goes dynamite. Alright? Cool. Moving on. G of f of 2. Work inside out. I know you're going to get real sick of me saying that. I'm plugging 2 in over here. Okay, so it's 4 times 2 squared minus 1. Where am I getting this from? Right here from my f. Do a little mental math. 2 squared is 4. 4 times 4 is 16. Minus 1 is 15. Hopefully you guys are cool with that. Bring this down. Okay. Now, I'm plugging this into my g. Square root of 3 times 15. Square root of 45. I can break that down to be root 9 times root 5. 3 root 5. Okay? Just a little bit of simplifying down square roots. Good little review for you. Part C, f of x. This one always throws people off, but you're doing the same exact thing, just twice. So, my f of x is 4x squared minus 1. Okay, now think about this with me. Now I'm putting this back into f. My f is 4 something squared minus 1. What am I putting in here? The last thing in the parentheses. Okay, so the 4 chills out front. I have to FOIL this all out. I'm going to go ahead and do a little thing. Okay. Alright, and then you can FOIL this 4x squared minus 1 out. 16x to the 4th minus 8x squared plus 1 minus 1. Okay. This is, if you need to, you can do the work off to the side up here. Square, and you can FOIL it all out. Distribute the 4 in. We get 64x to the 4th minus 32x squared plus 4 minus 1. And finally, 64x to the 4th minus 32x squared plus 3. Okay? Alright. Let's take a look at our last little bit here. Given 3x negative 1, I'm just going to encourage you guys, when you see this, rewrite it as 3 over x right away. Okay? Because it's x negative 1, you flip it, and x plus over 2. So here is f of g of x. Inside out. G of x is x plus 2. Okay? Now look at your f. F is 3 over x. 3 over something. Okay? The something is this last thing you put in there. All's well. Here we go. In reverse, g of f of x. Okay? So inside out, my f of x is 3 over x. Alrighty. And then my g is x plus 2, something plus 2. Here's your something, 3 over x. You can leave it like that if you really want to. You can bring it down to 3 over x plus 2. Either one's fine. Okay, and finally, g of f of 5. Now, f of 5, you're plugging the 5 in for your f function, is 3 over 5. Okay. Now look at my g of x function. It's something plus 2. So it's 3 over 5 plus 2. Get a common denominator. Let's see here, 10/5.
Mr. Howard, if you're in the building, please come to the lower house office.
I'm always a wanted man. There we go. Perfect. So that wraps up the notes for today. As always, keep the good work and good luck. We're all counting on you.